right, today we are moving on to combining like terms. Nothing too new. You've done it many a times. We're upping up the lesson in rigor by including integers in there, so positive and negative numbers. That's all that's new today. Okay. Your I can statement, I can simplify expressions. Simplify means smush a large expression down. Okay. Vocab you need to know. Terms. Terms are part of an expression. Part of an expression. They are the things that make up the expression. So, if I had, this is an expression down here, 4 plus 3x plus y plus 7. The terms are what is a part of it. So the 4 is a term. The 3x is a term. The y is a term. The 7 is a term. It's the different parts of the expression. Okay, if you think about it in real life, I have a class, you'd be like my expression, and each individual one of you would be a term. Okay? Like terms have the same variable connected. Like terms have the same variable or letter if it's easier to remember. Okay? Like terms have the same variable connected. So 4a plus 5b plus 6a plus 4b. 4a and 6a are like terms. They both have an a. 5b and 4b are like terms. They both have a b. Coefficients are huge, a huge vocab. They are numbers that are in front of a variable. Coefficients are numbers in front of variables. Numbers in front of variables. Example, 3x plus 2. The coefficient here would be the 3. It is the number that's in front sticking to the variable. 4 plus 2y. Which one is the coefficient there? 2. The 2 is the coefficient. It's the number sticking to the letter. So this is the coefficient, 2. A constant. Constant has no variable connected. It doesn't vary. It is constant. Doing the 3x plus 2, the constant would be the 2. It doesn't have a variable. The 4 plus 2y, the constant would be 4. It doesn't have a variable. So there's constants and there's coefficients. Those are two terms of an expression. Okay, next page. All right, we're going to identify parts of an expression. And when I identify, I'm just labeling. So I have this expression, 3x plus 2y plus 4x plus 3. That's just the expression. I'm not doing anything with it. I'm looking at this next line. And I want to know what are the terms of my expression. What makes up the expression? Judah, give me one. 3x is one term. Yes, that's a term. What's another term, class? 2y. You can just say it aloud, guys. 2y. A term makes up the expression. It's the different parts of it. What's another term? 4x. Making it up. Making up. What's another term? Y. And what's the last term? 3. And that's a constant. It doesn't have a variable. Like terms. Which ones on here are like?
4x and 3x.
Yep, 4x and 3x are like terms. What's another like term?
2y and y.
2y and y. There. The coefficients. The numbers sticking to the variable. What are the coefficients in this expression? Judah?
3x.
Just 3, just the number. Jacob? 2. Austin?
4.
4. There's another one. What's this other one? Austin? 1. Yes, 1 times y. Exactly. And the constant. Which one is the constant? Which one has no letter sticking next to it? 3. There, we identified. We identified parts of an expression. All right, how we're going to apply simplifying expressions is through combining like terms. And when we combine like terms, there's a few facts that we need to know. If there is nothing in front of the variable, it is a 1. Okay, so if there's no coefficient, if there is nothing in front of it, the variable or the coefficient would be 1. So if there is nothing in front of the variable, it is a 1. You just don't write it down. Mathematicians don't write 1x, 1y, 1a. You just write x, a, or y. Okay? If there is a minus sign in front, you want to make sure you add the opposite. If there is a minus sign in front, if there's a subtraction sign in front, make sure you add the opposite. And that is the 8th grade standard there, as being able to apply integer operations with combining like terms. So, looking at this, I always start at the left. I look at this x. This is a 1x. So when I say, who am I going to connect the 1x with? The 4x. 1x plus 4x is equal to 5x. Okay? And then the constants are like terms as well. 4 plus 8 is equal to 12. That is my final simplified expression. 5x plus 12. It is not 17x. I want 100% of my 8th graders to never write 17x. That's what so many kids love to do. Don't love it. Love keeping it like this. Do not combine unlike terms. 3s plus 4f minus s plus 3f. Oh my goodness. It says, according to the second step, it says if there's a minus sign in front, make sure I add the opposite. I do see a minus sign in front, so I'm going to change that to plus a negative s. So now I have, starting from the left, 3s plus a negative s. How many s's do I have? 2. I have 2 s's. Now I have my 4's. 4f plus 3f. How many do I have? 7. Right? I have 7 f's. Can I combine them?
Yeah. No.
No, I have an s and an f. They don't even like each other. They're not alike. Okay, so I leave it as is. The next one. Again, I see a lot of minus signs going on, so I'm going to add the opposite. So right now, I want you, where you see the minus sign, go plus a negative. Okay? All right. So you should have had to do it twice, and I rewrote it as plus a negative. So now I'm just starting at the left. Negative 4x plus a negative 6x. What's negative 4 plus 6? No, negative 4 plus negative 6 would be negative 10. Plus 3x, negative 10 plus 3, negative 7x. Okay? Now I have positive 3 plus a negative 5. 3 plus negative 5 is what? Plus a negative 2. And I am done. I have simplified my expression. That means I have combined as many like terms as I could. This one's huge. I want you to try to do this one yourself. Okay, first step with this last problem. What I'm going to do is change any subtraction into plus and negative. So this minus 2b says plus a negative 2b. And I have a minus 8a is plus a negative 8a. There. Done. Now I can start combining. So I start with my constant. I always just start with the left-hand side. My constant is 13. Are there any other constants? A b and a 5. I can connect it with a 5. So 13 plus 5 is 18. And addition is commutative, so order doesn't matter. You can flip these around as long as you have the same things as me, the same signs, you're good. The next thing I have is the b. This is a negative 2b. Negative 2b, it looks like I have plus 7b. What's negative 2 plus 7?
5.
5. So negative 2b plus 7 is a positive 5b. And a is my last one. So I have a positive 12a, and I'm adding a negative 8a. What's 12a plus a negative 8? Say it nice and proud for me, please.
4.
I have 4a. 12a plus a negative 8a. I am left with 4a, positive 4a. Can I combine these, yes or no?
No.
No, so right now, I'm going to leave it as is. Whoops. I do want you to know that I'm going to kind of leave it like this, but proper math etiquette wants to put variables first and then constants last. So I should, and it should go in alphabetical order. So this technically would look like this: 4a plus 5b plus 18. Order doesn't matter though, so I'm okay. I want us to look here and write some guiding questions on the left-hand side. So what we need to do is think about the topic. What did we just talk about? We just talked about combining like terms and some important rules for combining like terms. Our rules were, if there's nothing in front, we put a 1 and change any minus into plus and negative. Okay? So a guiding question would be like, what are two rules for combining like terms or properties? And then the last section was all about examples. So it could be, how do I combine like terms? And you see, I do all about the patterns. It doesn't help you much if you don't distinguish the like terms. Notice I color-coded. I changed, if you just have a pencil, I changed from lines, from lines to polka dots. Okay? I'm just distinguishing the separate like terms. So this section is all about examples. How do I combine like terms? And how you answer that, how do you do it? You distinguish what's alike and combine them. Okay? And that's all worked out examples. Switch the page. We talked about identifying parts of an expression on this page. And that's about all we did. So I could say, what are the different parts of an expression? And we can answer it on the right-hand side by saying terms, like terms, coefficients, and constants. What are the different parts of an expression? And the different parts, I should be able to answer this question, are terms, Like terms.